Hi, this is Ms. Delosier, and these are your notes on Newton's law of universal gravitation. And this is a little different than what we've talked about with gravity in the past. I know that you guys understand that gravity is what makes things fall down, but we need to talk a little bit more about that. So let's go ahead and let's look at that. This guy right here is Isaac Newton. And you guys have probably heard about Isaac Newton before. You've probably heard a story about how he was sitting under an apple tree and an apple fell on his head and he was like, aha, gravity. Well, sorry to tell you that it's not quite that simple. So really, people knew that, stuff pulled stuff down to the ground. I mean, it wasn't like anyone thought that the apple was just going to float up into the air by the time Newton was alive. What was different was that Newton realized that that apple would fall straight down perpendicular to the earth from the apple tree where he was sitting, or an apple tree anywhere else on the world. It's going to fall straight down perpendicular from wherever it is, and it's always going to fall straight down towards the center of the earth. And everyone kind of knew that. That was kind of like a duh thing. But what Newton was really brilliant and able to figure out was that the moon was being held in by that same force. So if you think about it, the moon is being pulled down towards the center of the earth, and when the moon's over there, it's being pulled to the center of the earth, and that's what holds the moon in its orbit around the earth. So Newton was able to go ahead and take that realization and go ahead and be like, all right, well, that must be what holds all the planets in orbit around the sun. And that was kind of a big aha. And he was able to go ahead and figure out, what is that relationship? It wasn't just gravity holds stuff in orbit. He was able to go ahead and say, why? And so what he was like, okay, there's an attraction. And that attraction between all things is going to be gravity. So all things are attracted, and that's gravity. And so this is basically what he said. He said any two objects with mass will be attracted to each other. Now I know that you're thinking, hold on, wait a minute. Oh, by the way, that's gravity. That's the force that we define as gravity. And I know you're all thinking, okay, hold on, wait a minute. That means that I'm attracted to the person sitting next to me. Like, not like, attracted to the person sitting next to me, like I'm attracted gravitationally to the person sitting next to me. And you know what? That's true. You are gravitationally attracted to the person sitting next to you. You're gravitationally attracted to your iPad. You're gravitationally attracted to your desk. You're actually gravitationally attracted to the ceiling. So here's my question. So why don't we all fall into, instead of just falling onto the ground, why don't we all fall towards all objects with mass? And here's the answer. Because the Earth's mass is so much greater. So because the Earth has the greatest mass of anything that you're ever going to be exposed to, you're only going to be affected by the Earth's gravity. So we know, and Newton was able to figure out, that gravity had to do with the mass of the object. So you have a relatively small infinitesimal mass compared to the mass of the Earth, right? So you're not really pulling the Earth towards you in an amount that we can measure. I mean, mathematically, are you pulling the Earth towards you? Yes. Are we going to actually be able to see that? No. So let's actually look at mathematically what we're doing. So it's not just going to be based on the gravity or on the mass. It's going to also be based on the distance between them. So let's imagine that, again, we have the Earth and the moon, and we're going to go ahead and we're going to look at the distance between those two objects, and we're also going to look at their masses. So mass 1, mass 2, and the distance. The greater the distance between the two objects, the lesser the attraction of gravity. Okay, so you have a relatively small mass, but you're sitting on the Earth, right? So your mass is not going to really affect the Earth, but the Earth's mass is greatly going to affect you. The moon has a really large mass, but it's not as big as the Earth, and it's really far away from you. So you don't really feel the attraction of the moon. However, the tides, like ocean currents, are actually based on gravitational attraction of the moon. So how do we calculate this mathematically? Because I know that that's what you guys care about, and disclosure, I don't care about this. Just show me how to do the equation. So this is the equation. We have the force of gravity is equal to big G, not little g, big G, times mass 1, mass 2 divided by the distance squared. Now, I'm going to give you the equation anytime you need it. It's written on the formula chart, but let's review what these letters are. M1 is just the mass of the first object. M2 is the mass of the second object, and D is just the distance. So, what is big G? Big G is a constant. It is 6.67 times 10 to the negative 11th Newton meters squared per kilogram. I know that's a super complicated unit. Luckily for you, it's written on the formula chart. You do need to be able to go ahead and do 6.67 times 10 to the 11th, though, and use that in a calculation. If you're not already using my script calculator, I strongly recommend my script calculator when you first start doing this, because it's going to be really difficult for you to type these into the calculator. You do need to be able to use the calculator, and that's why I think you should download my script calculator on your iPad, because that way you can check and make sure you're doing your work right. If you're having issues, you need to come see me. So what is G? G is 6.67 times 10 to the minus 11th, and that is the universal gravitational constant. So constant. So big G, 6.67 times 10 to the minus 11, little g, 9.81, and those are both on the formula chart. So let's go ahead and move on to the next quest and do some practice problems.